Here and now we present to you a video involving Witek, who have kindly provided me with equipment to demo for you and dismantle and talk about. Yes, thank you Witek for sponsoring today's video. Ciao, thank you. Bye guys. Alright, let's look at another switch from Witek. And what do we have here? Boop. What have we got? Alright. Okay, so this is the WI-PMS 310GF Alien. 8-port, 1 gigabit PoE plus, 2-port, 1000 meg SFP. And it looks like it's 110 to 240 volts AC. This one has an IP address on it. Well, that's a little concerning because the DC switch doesn't. Alright, so let's see here. What do we got? So we got a switch. Let's get a switch. Goes over there. Alright. Okay, what do we got for a switch? Okay, and what's in the box here? Because this comes with another box inside of a box. It's like a nested box. It's Inception of boxes. Well, we got a power cord, but again, no mounting options. That really doesn't make me happy. So let's put all the crap in the box, the shipping stuff, because at least they ship these well. Okay, so let's see here. All right, so what do we got here? 8 gigabit Ethernet plus 2 SFP, 24 through 48 volts managed PoE switch. Green, 48 volt. Orange, 24 volt. Link, green, 10100. Orange, 1 gig. And there's a console port on here. That's handy. So the other switch that I was looking at is most definitely a dumb switch that you can either add or disable VLAN awareness. That's great. So these look like regular SFPs, but of course, the next part of this video will be to take a look at the spec sheet and take a look at the software. Alright, so let's do this. Let's tear it down. Yay. Alright, I'll bet you this. Oh, look, hold on a second here. DC in. Oh. You cheeky buggers. Oh, that's beautiful. Wait a second. So if this has DC in, this might be the DC switch that I wanted. Okay, so this is DC capable. So you can either run it on AC or give it 54 volts DC. Oh my god, if that's the case, that's fucking awesome. Alright, let's take a look at this thing. Today's video brought to you by Witek. Alright, how does this guy come apart now? Boop. Cool. Alright, so let's see. Oh, yes, they did do that. Okay, so let's just check something here. Alright, so we've got, this is the power board right here, but if you'll notice, the secondary power is over here. So this power supply, and look, we got some silicone on the cap there. That's cool. So this is a 48 volt, an AC to 48 volt power supply right here. Cool. Alright, we've got a couple of MOVs in here, so there is surge suppression built in. Awesome. Cool. Plus a fuse. Well, you need a fuse if you have MOVs, because if an MOV pops, it dead shorts. And that fuse, if it's not there, means bang, boom. All right, so we've got a, look at this. Okay, so here is our, oh my god, my OCD. Let's just, there. Okay, there should actually be a goob of silicone on each one of these guys because they are floaty components. And there should actually be one on the, inductors too. Cool. These gnats, they're making me insane. Gnat season, right? Because all the doors and windows are closed. So this thing has a separate power board. This is a buck board, it looks like. Although there are inductors on it. So we'll have to look at the spec sheet and see what it says. Find out what this DC in will actually take. But let's get the power board off so we can take a closer look at this. And look, there's also a DC jack here. By the way, there's a little bit of leftovers here from the wash. Let's see, well that, Alexa, turn off workbench. Here we go. Okay. Let's see here, is that biological? Oh, it doesn't jump out. Oh, what's this over here? Some goop here. Is that goop? That looks like flux. Is there some flux over here? Cool. Alexa, turn on workbench. Okay, so, pop, pop, poppity pop. There we go. All right, so, oh, you see this? Just opened it up. Look at this. I just opened this up for the first time. That's not cool, guys. Look, that capacitor isn't even seated on the board. Oh, wow. And trust me, I did not go in there and catch that with my tweezers at all, because I went in like that, so I didn't catch that guy. So we have a loose cap sitting here. You know what? We're gonna have to resolder that, so give me a second here. I'll get a tip on here. Just a tip, and use this one. Let's fix that before we do anything else. Are there any more loose caps? This is why you put silicone on parts. You know, you caulk them with a proper silicone caulking to ensure that they don't come loose when you ship or move them around. There we go. Bloody hell. That is frustrating, man. There is a lot of thermal mass to this board. Okay, let's get this guy cleaned up now. Should probably use my heat gun to stick this on here, but you know what, screw it. You never have enough flux. Flux it. Flux it. There we go. Flux. Let's drop you on here. And by the way, these capacitors are keyed. You see the shape of that and the shape on the board? Most SMDs are actually keyed that way, so let me bring the temperature up a little bit. I need just a little bit more. Here. There we go. So that's one side. And, ooh, I want to shove it over just a little bit. Let's do this side now. Don't be afraid of the mighty soldering iron. Be afraid of blowing components up. It's getting a little hot. I'm gonna have to cool it for a sec. Alright, yeah, we don't want to burn this cap up, so I just get in here. What a shitty spot to have to solder on. Really, I could have just done this after I took the board out, but I'm an idiot, so. There we go. Let's put a little bit of heat on this side. And yeah, I would say that that's solid. Yeah, that's not cool. Don't like that at all. Alright, so what other flaws can we find in this now? First of all, let's take a quick look at the power board. So we got some TVS diodes on here. Really dirty. Like, look at this, like this flux. There's like, these boards are supposed to be scrubbed before they actually go out. And I'm not seeing that they were scrubbed. There's still like dirt, you know, on these. Hasivo PSE 8-port AOTO 2C 2.0 version 1.01. So this looks like a third-party board, maybe? All right, and we got this cap here, raised over top of, each one of these caps is raised over top of a really heavy-looking ceramic capacitor. And actually, I didn't like the looks of this one because the solder doesn't go all the way through the vias on these caps here. So, I mean, these caps are basically floating on one side. That's not great. I'm calling poor build quality on this thing. Maybe I've had people tell me that these guys have a tendency of failure, and I want to give them the benefit of the doubt because I want to actually like try these switches out because we don't have a lot of options right now. So I'm just hoping that these are a win, even if I have to modify them to make them a win. I really don't care at this point. But yeah, QC passed. Not great. Not very impressed with this right now. You get what you pay for in most cases, right? So just remember that. So it's like, ow, why can't somebody make a dual voltage PoE switch that for like $100? Because you're a crackhead. Figure it out. It costs money to make this shit. Research and development goes into this product, and then of course that's just the development process, right? And then you actually have to get them manufactured. You have to find all the components to make these guys do what you're going to do, and so there's a ton of work that goes into these guys. And the reason why a lot of guys won't get into doing stuff like this, in fact, is I've been trying to get manufacturers to develop a PoE switch of my design, and nobody will do it. And one of them outright told me, and you know who you are because you're one of my boys and you're awesome, but he told me straight up, I'm not interested in making WISP switches because I'll never be able to make it cheap enough, and people won't pay the money for it, so it's just not worth making them because I'll lose money on it. And you're not wrong, but, you know, people are trying, so people need to eat too. So what do we got here now? Okay, so that board's prepped. It looks like we've got some, so this is good. Look at this. Okay, so they actually did some epoxy here, or this might be B7000 black. It is definitely a rubberized compound here on the heatsink to hold the heatsink onto the board. And it looks like they also use thermal epoxy here, which is great. There's a bit of contamination in that header. Okay, so we got our inductors and stuff here. So this is the DC in right here. So we'll have to check the spec sheet because it looks like this whole power section here is, how do you say that, superfluous? It's redundant. You can either plug it in through AC or give it DC input. That's badass if this will do that. Cool. What's it say on here? Managed Auto RTL 8 gig plus 2S version 1.01. We got some nice coupling transformers in here. This is a Realtek chip up front here. It's an RTL 8231. That's probably for the SFP here. Or it could be a serial interface chip. I'm not going to bother looking it up. If you want to, look it up for yourself. It's a Realtek RTL 8231 right here behind the console port next to the SFPs. The SFPs, although, do look like they go straight to the CPU, which is very common. So this might even be a switch. No, that's too small to be a switch chip. It looks like everything comes off of this switch chip, this switch fabric right here. Let's just do a quick poke on these other components and make sure that none of them are loose. Cool. All right, so let's take the let's take this board out now and take a quick peek at it. Yay! What I'm probably going to end up doing to test this thing for you guys, by the way, is I'm going to take my my Natonix, the one that's on the rack in my other room, and I'm going to replace it with this thing and try it for a week and see if I have anything to bitch about. Okay, there is a nice thermal coupling below this. I can feel it. Yep. Okay, so let's see here. All of you, get on here. That. No, yep, that. Yeah. Damn it. Now my screwdrivers are magnetized. That's the last thing I really wanted. Okay, there we go. Power supply, we will put you aside. Nice. That is really nice thermal compound right there. Okay, let's put that aside now. Flip her over. What do we got here? More of this horrible gooey stuff. Alright, so here's where the thermal conductor pad goes. There's lots of scratches on these boards and scuffed, which means that they weren't actually gently handled in the factory. When you see scratches and stuff like that, that's usually because it dragged across another device or component. Because watch, take my tweezers, and I'm just lightly rubbing it across like so, and I'm not seeing anything. See the scratch here? To simulate that, yeah, I gotta push fairly hard for that to happen. So this looks like these boards were all just in a box or something, like just sitting on top of each other without any protection. And what's this? There's actually a piece of copper wire. This piece of copper wire is stuck to flux right here. This could actually be from a solder braid right there. And look, there's more of it right here. That actually looks like leftover solder from an electrical arc across here. And there's a bunch of that on the back of this board. So the quality control on these guys is just extremely subpar. Yeah, no. I think I want that one. There we go, that'll work. So now to repair, oh, is that the right one? Nope. Not winning. There we go. Just tighten this guy on here, we should be good to go. Let's move my ISO before I make a mess out of it. There we go. That guy's on there now. Okay, so what we do to fix bad solders like this is I'm going to get a little bit of flux, and I am going to stick it on here. I am right-handed. Now, you got to be careful because there's some capacitors around here, right? I might hit it with the soldering iron, too. If I can just hit it with a little bit of heat and get her, I will, but we're just going to give this a shot. Actually, fuck. That FET there has no solder on it. It's dry. Shit. You know, it's kind of not fair that I'm actually going at this thing and fixing it before I'm using it. Because if I just... even oh, holy crap, even more. Look at the BIOS here. This is lacking solder. It's like real dry for solder on this chip, too. That's going to cause problems like, you know, when the unit starts working and actually passing current, it'll actually crash. This is like really poor quality. Here we go. So I'm going to try to hit this chip without actually popping the caps around it. I think I got it. How's that cap? You know, it's getting a little warm. Give me a second. I'm just going to put this pair of tweezers here so I don't hit that cap. There. I think I got that one cleaned up. Alright, let's just take the iron and we'll touch up the other ones. Jesus, this is I did not expect this to be such a mess. I'm sorry, folks. Honestly. Yeah, like, Christ, the solder on this, the soldering job. I'm shocked, honestly. Now, I don't want to be one of these savage arseholes who does a review on a product and, you know, and gets all snotty about it, because I'm trying to help both the companies and the customers connect, right? This is why I do what I do, is to help all of you guys. It's not just one side or the other. It's connecting people. But in the case here, I honestly did not expect this. This is really bad. It wasn't supposed to turn into a repair video, guys. Just make sure I'm still recording. Wow, we're on 24 minutes already. That's nuts. Let me just, I'm just gonna bring this down here. Sorry if it's in the way, guys. Like I said, I was not planning to do a repair video today. I haven't actually done a repair video in a while. Let's get some of this yellow cum. There we go. Okay, so we got these guys touched up. Not magically, but really gonna goober these ones. Let's see here. This is a lot harder to do without a microscope, guys. But you know what? I don't really do this kind of precision work anymore, because that's what Thomas is for. Thomas does all these repairs while I focus on the consulting, right? And sorry if my big fat head's in the way, by the way. There we go. There's one side. Start over here by this cap so I can get that one out of the way. That's my exhaust fan trick, is you blow the flux out of the way when you're soldering. There we go. So that chip's fixed, and now I just want to double down on these guys over here. I gotta be careful of these capacitors. I don't want to wreck them. Oh, my tip is raw. Let's dial down the temperature a little bit. I'm cooking these guys a bit too hot. That's what it is. So I'm getting contamination on here. Let's see. I really should also be doing a blade tip for this one, but whatever. Let's see here. Come on. Won't wet. There we go. That could have been why these guys don't have a lot of solder on them, is they didn't wet during the flow process. Because they usually use wave soldering to do these guys. I'll put a little bit more on here just to be on the safe side. There we go. Fix that one. That's our cap to it. And now for the last part, which is our, I really need to clean my sponge. That's what denim's for, I guess. I'm just going to go over these guys just quickly, but before I touch that chip again, I'm going to put a little bit more flux on it. If anybody can tell me where you get the flux that smells like cookie dough, please hooks me up. It's really hard to find now. There we go, that's much better. In some situations, a little bit more is better than none at all. There. That's 100 times better. And I can actually see a couple of pins over here that may potentially suffer from cold solder. Let me just poke at them. No, they're okay. Yeah, the solder, like, it's almost like there's not enough solder on this board. They didn't flow enough solder onto the board, which is why we're seeing all these problems. And this is actually consistent across the other switch as well. I noticed it was lacking in solder, so inconsistencies with operation would definitely be due to a lack of solder on these guys. So I'm just going to call that good enough for now, and if that fixes it, it fixes it. Now, of course, the last part here is we need to clean off the flux. Because you know what? Don't be a pig. Go. And of course, in this power section of this board is where all the friggin' problems are. Like I said, my buddy was telling me that he uses these and he had problems with them shutting down and power cycling after short periods of time. That may actually be because of issues like this, which is just poor soldering. And what'll happen is that there's not enough of a connection between the pin and the board, and it generates heat when the current starts flowing through. And it doesn't take a lot of current, like as much as like it's wattage. Think about it in the sense of wattage. So if you put like 5 watts through one of these pins and it's barely connected, it'll start to melt and it'll start to burn and arc. And then eventually the pin won't even be connected anymore. And then you'll get intermittent functionality because it'll heat up and then the pin won't lift, and then it'll cool and drop, and then heat up and lift, and then cool and drop, and it'll repeatedly do that. Let's take a... Christ, look, there's even more solder blobs on the side of this. Wow. Give these switches a chance, though, folks. I mean, we're going to take a good look at this thing and see how it works, because we're all looking for an alternative to some of the switches on the market. Look at the bad solder on these. Jesus, hold on a second here. Look, these actual pins here. So this is an LED pin, and this is actually... What's going on? It's like the via wasn't clean. Yeah, it's actually missing solder. So this is like bubbling because of contamination. Alright. There's holes. I don't know if you guys can see that, but there's little holes in these vias, like in the solder on top of these vias, which usually indicates that they didn't adhere properly, or there's contamination on the board when they actually put it through the wave. And these are on the Ethernet pins. And the LED pins. God, again, I did not want this to turn into a friggin' repair video. But, look where we are. Alright. This is just terrible, guys. Alright, so as far as a quality control pass goes on this is a fail. I would not let this leave my shop like this. This is really not cool, guys. This is... I didn't want to do a repair video, like, and this is what it's turning into now. And look at these guys. You got a power rail so friggin' close to this. Okay, so what is this one here? This looks like ground plane here. And it's extremely close to a positive rail. Hold on. What do we got going on here? Because we got a nice thick fat guy right here, which is going to 2 LEDs and the reset. And then there's a positive... Is that a positive? No, that's the ground rail right there. Look at how close it is to this pin, and there's like no isolation. And so if these LEDs are going to a GPIO, and there's a... I don't need to explain myself on this, okay? Just trust me. Clean that off. All my tips are like really clean right now for this. Alright, I think I've got most of these guys now. This one actually sucked up a ton of solder. That's not great. Got a little mountain now. Anything else missing more solder? Well, the mounts for the SFP cages are only partially soldered. It's like bare minimum here. But we don't need to really solder those. What they've done on the SFP cage is you can see 1, 2, 3, 4, 5, 6 anchor legs that are not soldered. And what they did was they just soldered the 2 at the front and 2 of the 3 at the back. So they didn't even solder the 3 at the back. So, come on, guys. It's just solder. And this one's barely soldered on there on the side mount. And this has contamination in it. This solder over here. Here's another pin, another via that's lacking solder. And there's a little bit of solder scrap left there in the SFP ports. So I have to say right now, the soldering job on this thing is absolute crap. I honestly don't think these things are reliable enough to put into a production environment without Look, okay, so here we go. I was looking for where that copper came from. It's hanging off of this. I knew it was copper wire. Get my little nips out here. Just gonna... There. That's where the copper came from. Over there off of that. It looks like they soldered it and then cut it and... Ugh. Alright, so I think we're done now. Let me just get this last little piece of solder out of the SFP pins. There. Okay, the SFP pins are clean. The solder, I'm going to put just a touch more solder on these pins right here. Wrong one. Where is it? I want this one. Put a little bit more solder, because you can actually see where there's a solder deficit here. That guy. That guy looks good. Sorry, guys. On the bright side, this is a good soldering tutorial, isn't it? And on that note, when you're soldering, you don't want a big bulbous blob on top, and you don't want it to be like right against the board. You want a nice little curvature like this. You want it to be like a slope upward towards the pin. So not too much, not too little. Yeah, I would say that everything's soldered properly now. Fuck, this is bothering me. I'm just going to solder these guys. I don't care. Wet it right into the via. There we go. Last one right next to these resistors here. God, that makes me feel better for some reason. There. Oh, one left. Sorry, I missed this one. Yeah. That's a lot of work to do that you didn't know that you needed to do before you put something into a production environment, right? So, to my cohorts out there that warned me that these switches can be janky, I see exactly what you're talking about now. And I take your I heed your warning, but I think that now that I've fixed all these problems, that this is actually going to be a decent little switch. We're going to try it out, okay? There we go. So that's all cleaned up now. I'm just going to double check to make sure I didn't leave any specks. Yeah, I got most of my flux off. No flux given. But you know what? Now that I've fixed all these problems that I have found, by the way, not, you know, the ones that I haven't found yet, if this is all that's wrong with these switches, then all that they have to do at Witek is just step up their quality control and their manufacturing process, and these might actually be a really decent switch. So that's all we can really ask of them, right, guys? Like, just step up your QC a little bit, and you'll have a really solid product. And yeah, so we're gonna jump cut now. There's bad flow on most of the boards. Like, I'm seeing some FETs that actually look like they're barely soldered. That's not great. That, like, once again, that's the whole, it operates for a little bit, heats up, and then stops working. That's when these legs of these FETs aren't actually anchored properly. Just barely enough solder to hold the shit on. I also want to test this. So let me just, we're going to actually look at the spec sheet on this. We'll probably revisit the switch after we have looked at the software for it in the spec sheet, because I want to actually make sure that I can plug 48 volts in here. And if I can plug 48 volts in here to run this thing, then we've got a DC switch. So, alright, sorry, I was starting to put this thing back together, and I was about to go and do the software part of it, but a couple of really important things I need to point out now that are major design flaws here. One, when I put the board back on, I showed you guys that there was a thermal compound, like a thermal pad underneath the CPU that basically bonds this to the chassis for heat dispersion, right? That thing is actually pushing up quite a bit on this. This board is actually domed right here where the CPU is, so that little pad is actually too thick by probably a couple of mils. I would say, let's see here, clear. see, millimeters. I would say 0.82 millimeters. If there's too much, maybe, no, 1.32 millimeters too much underneath here. It's actually pushing enough. I'll loosen up the screws on the front of the board so you guys can see. I'll lift all the tension off of them. There. If you look here, you can see that with the back screws in, if you look carefully, that's actually pushing up enough that's actually chewing up all the play that I've added here. So that's quite a bit of lift. That pad is pushing up down around the center of the board. Let's actually do this. So this is where it should be. It's right about here. So I'm gonna zero this now, okay? We'll lock this, or sorry, we'll zero this. So now let's see how much lift there is on this from the thermal pad. 2.28 millimeters of additional thermal conductor pad on the bottom of this, pushing up. So you can see me that's pushing up right there. That is not great. You're putting a lot of tension on this board and creating a bubble point here, which will actually cause the SMDs to actually lift and come loose. And here's another really poor product design, okay? All the header pins for the PoE board here, remember this header, this capstan here that's at the front of the board? That supports this. Look, all the headers are here, and the only mount is right here. Now watch this. If I put this in here, there's no mounts around the back. Okay, so let me just do this. Here we go. How's this guy going again? There we go. So if we put this board back in, there's only the one capstan here holding it up. It looks like it was supposed to have another one here, which would have been a good design, would have been better, and another one back here, but there's no capstans on the board. And if you look, so the screw here is cantilevering everything here, because you've got your header here and headers here, and that's it. There's no headers past this point. Right there, everything from here back is floating. And if you want to take a look here, well, this inductor here, that means that this is all floating right over top of this heatsink right here. So if this was to sag or this was to bulge, that will actually put these resistors and caps and everything against that heatsink. Let's see how much clearance we actually have right here. And what's up with this extra header? That is odd. There's like a double header here, but this header isn't actually being used for anything, right? This is an extra header. So what's even going on here? So make sure that our pins are all in place for the daughter board. We'll put this guy back in now. I need the screw for that. Or I'll just use this one. It's not like it really matters. There we go. All right, so now if we look down inside there, I don't know if you guys can see that. Let me see here. I wonder if I can zoom in. Let me try zooming in here. I'm gonna just zoom. There we go. And oh, there we go. Focus. Okay, let me get a light on that now. Hold on. Yeah, let's see now. Let's see down inside of there. Sorry about that. Here, let's see if I can. There, that'll get rid of that. So you see how much? See the heatsink there? Look. It's just hovering. It's hovering over top of that heatsink. There's nothing in there supporting this thing. Not a plastic capstan, nothing. Zoom back, go back to widescreen here. Alright, so from an electronics technician standpoint, this is extremely shoddy. Everything about this is poor. Wow. But like I said, if the functionality's there, and you can get the reliability out of this thing by simply stepping up the game on assembly practices, this could actually be a decent product. So we're going to find out anyway now that I've cleaned it up. Let's hope that there's no more poor solders on here. Yeah, now for another segment in the saga that is testing the switch out. So we need to see what this thing does for power now. So I've got a few items here on my bench. I've got a few standard items that the day may come to summon. Got a standard 24 volt feed horn here. This is a passive 24 volt feed horn. Got another standard 24 volt device here. We have got a PoE++ device here. We've got the security camera is obviously standard 802.3, and the caps as well are 802.3. Actually, these things are horrors. They'll work on anything. So let's start plugging things in. And at the same time, I have an OBS capture happening on that computer over there, so we can watch what happens. Try this. So first things first, I'm going to plug in right here, because the cool thing is this thing actually does auto-detect passive devices quite nicely, and the appropriate voltage for them. So security camera, go! And just to let you guys know, I'm actually running this thing on 54.4 volts DC right now through the switch DC plug over here on the side, so that's pretty cool, eh? All right, so this guy is now powered up. So let's go over to the computer for a second and do a refresh. Cool. All right, so if we look on OBS here, you can see that we've got active on, and it's showing current 57 milliamps at 53.39 volts. Power is 3 watts. That's pretty cool, eh? Up 2 watts because it's actually dipping. Now, if this thing's infrared kicked in, it would probably drop a little bit more. Oops, there we go. I was tugging on things. Alright, so that's one item. So remember, folks, we're running this thing off DC right now, by the way. This switch here is running off of DC. Okay, so now I'm going to grab, let's try this PoE thing right here. I'm going to plug that into port 1. And plug that into here. And we can see that that guy fires up. Cool. Let's go back over to OBS. That's plugged into port 1. Cool, so that's drawing 53 volts. And actually now, let's do a little daisy chain here. I'm going to take this guy here, and I'm going to plug it into a 24 volt device, like this Bullet M2, yeah, M2, Bullet M2. Here we go, plug it in. Oh yeah, this needs active PoE to operate, so I think that this guy here is active PoE, 24 volts. It is. Cool. Alright, so now we've got the little CAP booting up here as well. You can see that this guy's negotiated. So this is active to active. It's just a buck converter for 48 volt to 24 volt active. Okay, so this guy's online now. So we've got a couple things on here. So now let's do a passive 24. I'm going to do this 2 ways. So 2 and 3 are set up currently so that they will, they're activated 24 volts rather than 48. So I'm going to do this. Okay, we're going to plug that into this Bullet, which I really don't care for, so I really don't care if it gets fried. And by the way, this is actually a dummy that I use for testing anyway, so the transmit is actually turned down to -4 on this. There's no SSID on here and it's set as a station. So this should not be cycling up. Okay, so that's plugged in there now. So that's plugged into one of the program 24 volts ports, and now let's plug into an auto-negotiate 24 volt port over here on port 5. And then we'll go back over to the OBS capture for a second. This is starting to actually kind of look kind of cool, isn't it? Ha! Alright, and that guy's booting. Cool. Let's see what kind of nightmare we've got going on the screen over here. Alright, so I've gone back over to my screen here, and look at that. Active on, because it's detecting that it's an active device, a proper negotiated device. Passive on ports 2. 3 and 4 are off. Passive on is, let's see here, you can see these too, because like, look, that's passive is 23. Cool, a little light, but whatever. I mean, it could be out of calibration. And the active is 53.3. Now, what is it that I plugged into, who's drawing the most power here? Here we go. So it looks like port 8 is drawing the most power. And what is on port 8? Let's go over here for a second. My computer. I think it means the security camera, which is actually plugged into port 7. So I'm a little bit confused here, because let's just take a look at this interface. So we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 is a passive because it's actually connected to my computer's USB dongle. So why is it showing that it's on? Oh, there we go. Passive off. Isn't that strange that it was doing that? I hope that it wasn't damaging my computer's USB dongle. Alright, but yeah, this is kind of cool. So we can actually see what these guys are consuming. They're all set for AT, by the way. Shows you your voltage and your wattage consumption. So these guys are handy. It will actually show you everything that you guys need to see when you're using a PoE switch. Everything's there. So that's a pretty cool little test. We've got everything going on here. And then, once again, let's take all this stuff out because we want to look at the hardware of this. Here we go. We're plugged into DC right now, through the DC port. Now, something else which I wanted to mention on this particular switch before I actually end the video is there's a critical problem here. I'm going to show you a couple of switches here. I'm going to show one that was sent to me by Lithium Joe, who's been a great sponsor of the channel, by the way. Thanks, Joe. You've been awesome. But here's the Cisco switch that he sent me, okay? And I'm going to be using this as a training video as well for you guys to teach you guys how to program Cisco switches. I don't know when I'm going to do the switch lineup, but I'm going to do it. But look on the bottom here. So look at all these safety certifications here. This is really important. We've got CE, EAC, CSA for Canada, Industry Canada. There should be an FCC code on here somewhere as well. Although this, yeah, where's the FCC sticker? FCC Part 15. All those? Now look at this one. Do you see any kind of safety certifications on here at all? No. There are no, there aren't any international safety standards on here, let alone North American standard, or, you know, safety inspections. So it doesn't look like this device has been properly safety certified, which I just noticed the other day. This video is actually spanning 4 days, by the way. Now, something else which I was concerned with is if you look at the actual power board itself, it's actually not a terrible power board in its design, but something which really bothered me, and I did test this and I did confirm that it is actually safe, is where's my pointing tool? So usually on a switch mode power supply, you're going to find that these two rails here are energized at about 400 volts. Typically what they'll do is they'll jump the voltage up and then drop it down through a buck converter so you get consistent power, okay? But here's the other thing. Look at how skinny the screwdriver is compared to my finger. I can barely get that between the switchboards, both the switchboards by the way, and this heatsink, which would normally be energized at about 400 volts. So that's something that really concerns me in there. I mean, like, what I would do if I had this switch in operation, which it is going in operation here in my home, is I'm going to take the power board here, toss it aside, and only use the DC on it. But let's do a quick test in here, just to be on the safe side. Okay, so I'm going to give this some AC power here, so I'm trying to be thorough. All right, and let me grab a set of probes here. We're going to put a positive on here. And I want to use a negative probe. Negative to the chassis, because I want to see if this thing will zap you little fingies if you touch it. So we're going to go to a ground on here. We're going to go to the chassis, and we're going to plug this in here. Now we're going to poke around. Okay, so first of all, let's check the DC on this thing. Okay, yeah, so we've got no power. 1 millivolt. So this is actually almost an isolated power supply, by the way. Let's check the DC port on this thing as well. So, like, I can actually touch this thing and not get zapped. I feel some tingles here, but that's not amazing. Let me just slip this. I'm gonna slip this into a ground on my plug and see what we actually get here. And it looks like this is completely flat. In fact, I can actually plug this into my power supply. I wasn't even thinking. My power supply has a grounded port on it, so I'm not getting a zap off that. There's nothing. So this is actually fairly neutral. And actually one last test. Let's test across these. I'm getting no juice there either. So for switching power supply, this is actually a very simple power supply. But here's the other thing though, is it looks like there is electrical isolation between the actual switchboard, which is good because you can use this in plus or minus plants. You can use it as a negative 48 volt switch. We're gonna go like this. So if I touch this, you can see that we get continuity, right? Move this over here so you guys can see it better. Here, continuity, right? Let's get rid of this AC cord, by the way, it's bugging me. Now let's touch one of the pins on here. If I touch it to center, I get nothing. If I touch it to sheath or jacket, I get nothing. So there's no reference, no chassis reference anywhere on this board. This is a completely isolated board, which leads me to another question. Okay, so cool. So the electrical section of this board is completely isolated from chassis, but the Ethernet ports are not. That's actually really good. I'm happy with that. That's actually very good. Look, like that's awesome. So the power components are actually isolated from the chassis on this, but the actual cool, the Ethernet ports are actually grounded. Yeah, there's no reference. There's no actual bonding between any of the data circuitry and the chassis on this hardware. It's basically just the ground is the ground where the ground is. There's no data or electrical reference at all to the chassis on that, so that's actually pretty awesome. Yeah, so basically this thing right here, that's really the only problem in North America or any other European Union or any countries that require certain safety standards to operate the equipment in their territories. But other than that, yeah, and that, and of course all the other stuff which I mentioned earlier, which was the crappy workmanship on the board, the poor assembly, the bad soldering, the potential for the whole board to dome and cause the CPU to delaminate from the surface of the board, all that stuff. Other than that, actually, if this thing didn't have so many flaws with it, this is actually a pretty decent little switch. So that's that. Cool. All right, on to the next part. Check. Okay, so this is for the Witek dual voltage AC/DC switch here, and I'm just going to get this out of the way and recording in for the spec sheet and the web interface functionality. So let's see what this little manual has. How many pages do we even have here?
Witek Communication Solutions.
All right, highlights. 8 gig plus 2 SFP full gigabit switch. Cool. Internal power adapter supply, 150 watt output power. We're reading a manual, folks. This is like reading The Great Gatsby, I guess, with a stoic, straight expression on stage. L2, L3, L4, QoS, and IGMP snooping, optimized voice and video application. Wonder if that means it does DSCP as well.
Supports short circuit protection and overcurrent protection. The output power of each PoE port can be remotely modified to 24 volts or 48 volt via the user management page. Oh, I can't wait to look at that. Here's a little striptease. Oh, there. Okay, going back. All right, supports spanning tree and rapid spanning tree. Cool. Up to 4,000 QVLANs simultaneously. VLAN? Link aggregation control protocol, LACP, I would expect nothing less. Web CLI, manage modes, SNMP, bringing abundant management features. Typical applications. Hey, is that a Cisco desk phone? Oh, huh. All right, yes, that's kind of obvious. 8 gig layer 2 managed switch. Let's see here. Provide for high performance, blah, blah, blah. I'll provide the link in the description. I'm looking for things that jump out at me to, oh, here we go. IP MAC port VID binding. This basically has pretty standard switch software running on it, by the way. I've been through the CLI and I've been through the GUI, and it's pretty similar to a lot of the other industrial switches I've looked at. Secure networking, advanced QoS features. Here's this hardware specifications once again. Network 10 base TUTP category in 3 and 4. Here we go. Hardware features. Let's take a look at that. That looks interesting. That's more my neck of the woods. 5 cable. What? Maximum 100 meters, 100 base. Cat 6. All that cool stuff. Fanless. Yep. Power consumption 150 watts. Max with PoE devices connected. External power supply. That's what I'm looking for. Uh-oh. I'm sure it'll do 54 volts. I'm sure it'll do 54 volts, but it says 52 volt 2.8 amp in, or 110 volts. Standard 802.3 AFAT compliant, passive 24 volts, PoE ports, cool. All right, exchange capacity 20 gig, cool. Packet forwarding 14.9, what? Oh, yeah, mega packets per second, or a million, whatever. MAC address table 8K. 1.5 megabits jumbo frame. Oh, it does full jumbo frame too. Okay. Look, it does DSCP. Awesome. Dull. Pause it if you want to read this, by the way. Dull. Oh, there we go. Working temperature. -10 Celsius to 55 Celsius. Can you say heated enclosures? 10% through 90% relative humidity. Non-condensing, storage humidity, blah, blah, blah. Is there anything else in here? No. All right, cool. Bye-bye. Let's go back over to the Switch now. Ha! Here's the GUI for the bloody thing. Isn't that cool? Signing in. Admin. 192.168.0.1. Cool, eh? Kool-Aid. Yep, okay. So, what do we got up here? System configuration. So, first of all, by the way, here's this cool stuff. I should take a look at what chip this board is using. I'm kind of tempted to actually rip it off and check it out. I could do that. Tear the heatsink off and then lap it, maybe. So let's see what the system configuration menu has. Basic information. All right, yeah, cool. Cool. System contact. Leave me the hell alone. There we go. Let's apply that. Cool. Isn't that fun? All right, so we've got that. Let's see. The serial information is right here. That's for the serial interface, clearly, which is kind of handy. User management. Cool. You can actually put numerous user accounts in here. I like that. That's really handy. That's really handy, actually. I wonder if it supports radius. Safe management. Okay, so safe management is clearly the interfacing functionality. It doesn't support secure protocols. Are we sure about that? Let me try something. No! Are you telling me this thing doesn't support SSH? Come on! Oh, maybe I don't have Telnet installed on here. You know what I'm going to do, though? Just to be sure. Where's my Nmap? Hey, Nmap, I called you. Oh, it showed up on my TV, which is way up there. Which I don't think I can get to it. Bloody hell. Let's try this then. Hold on. Alright, let's just do a quick port scan on this thing and see what's open here. And I'm going to put that down on the lower screen for now. But yeah, it doesn't support HTTPS and it doesn't support SSH. That's not cool. Are we sure about that? I guess we'll find out in a minute. Alright, well it says right here SSH. Huh. Just gonna try this one more time then. Here. Interesting. But Telnet's open and HTTP is open. Well, that is really odd. Okay, well anyway, moving on. I focused way too much on that user safety configuration. Yeah, I'm probably just misreading it. Let's take a look at this. SNTP. Cool. Hey, this thing has, let's do a whois on this just for shits and giggles. Alright. Let's look up the stock IP for the SNTP server. That didn't work. Let's try this. Who is? Nope. Maybe this one won't want my credit card information to process. There we go. Asia Pacific Network Information Center, AppNet. Cool. City, South Brisbane, Australia, eh? Huh, isn't that interesting? And let's see who the other IP is on here then. You know, this is just, you know, being a little bit, snoopy. What do we got here? Same, AU, AppNet. And then there's this one. Let's see where that one goes. Let's see here. National Center for Atmospheric Research. That's an interesting IP. What's that one for? Server. Oh, okay. Well, that's for the time. Yes. Okay. Cool. All right. Save current configuration. Cool. Yep. There's your CLI configuration file. Yeah. Whatever. File upload and system reboot. Yay. All right. Let's get rid of that one. What do we got on the next menu? Port configuration, common configurations, port stats, flow control, broadcast storm. I wonder what this all has in it. I'm just gonna poke around, pause it where you want to see it. This way, like, this is kind of a cheap and easy way for you guys to get a demo of a product. Pause it on the screen that you want to watch. I'll hover for like 10 seconds on each one. Port trunking, DDM, handy. Mac bindings, yay. Let's ARP. Mac filters, cool. VLAN configuration. So I'm gonna have to learn how to do VLANs on this Switch because I do have a series of videos coming up where I show you guys how to do VLANs and how to program switches, okay? And by the way, once you learn how to do VLANs on one of these ones, pretty much all of these switches that have the similar interfaces on them will program fairly similar. Okay, let's see here. Standard Mac IP ACL. Magikarp. Carp. There we go. Cool. QoS. Let's see what we got for QoS. It's kind of handy. Ha. Cool. Okay, so it's got DSCP functionality, IP basic configuration. Here we go. So this is where we would configure the IP address for the unit. Our configuration and display. Cool. You won't see much because I've got this plugged into an Ethernet adapter hanging off the USB port on the front of my computer. We got AAA. Let's take a look at all these menus so that you can see what the hell's on here. Oh my god, this is boring. Feel free to grab a beer or, you know, whatever. If you don't drink, then I apologize. Go get some, like, I don't know, some Zima and sushi. Something, I don't know. Drink some water. You know, I'm actually up to 3 bottles of water a day. Ha! It's really good for big fatzos like me. At least if I'm fat, my kidneys and liver will be clean. Let's see here, GMRP. Cool. We're almost through the list, folks. Remember, I'm doing this so you guys can pause on the screens and take a quick look at how they work. Or what functionality's built in. Not Roman, Armon. There you go. Cluster management, because why not cluster a switch? Let's see here. NDP configuration. NDP! That should be orange, not red. Political joke. NTDP. Cluster configuration. There we go. Log management. Log. Everyone loves the log. Alright. PoE power control. There we go. This is going to be cool. I'm actually going to spend a minute here. So, I can select a port on here. Let's select all, and I can go automatic for voltage. PoE admin status. This is pretty damn cool. Look at this. It actually tells you quite a bit. You can go ATAF on this, which is awesome. Total power. So we can limit this so that we can do load shedding, kind of like I demonstrated on the Tycon switch there. And power consumption. This is really handy. So let's do a demonstration of what you would do on one of these ports. I'm going to do port 2. Or no, I'll do port 3. So I'm connected on port 3. So I've got it highlighted right now. I'm going to leave it on automatic PoE, by the way. PoE admin status. We're going to make it 18. You know what? Screw it. Let's go 24 volt. Watch. Fly. So now that just committed to change to that interface specifically. Neat, eh? So that's basically how you program that thing. You pick a port, and you change it to whatever you want it to be, and apply. There you go. It's literally that simple. And make these ATAF, shows your output voltage and stuff. And yeah, so PoE policy configuration. Oh, there's some cool shit. But what? But why? Wait, what? So you can turn off specific ports. I guess that'd be handy if you've got a hotspot running here. It's a feature. I'm sure somebody's going to love this feature, by the way. PD query configuration. See here. And by the way, it's been much longer than, how many minutes has it been? Will it show me on my OBS thing? No. But, all this time, this switch has not crashed yet. So, one of my colleagues who uses these was warning me that these things have a tendency of crashing. And after like 2 minutes. And so far it hasn't. And I think that's because of repairs that I actually did on the switch to ensure that that wouldn't crash while I'm demoing it. And like I said, we'll be discussing that with the manufacturer. So yeah, look at that. Isn't that cool? So this is what the switch has for internals. Neat. All right. Well, that's pretty much all there is to demo here. I think I've been in depth enough. Yes. So don't forget to like and subscribe below. Remember, I'm trying to bring you guys more content all the time. I am not sponsored by any one company. Each video that I do will be sponsored by the appropriate company that provides me with the equipment for said video. I'm trying to provide unbiased equipment opinions on all sorts of different things in the market because everything has a fit. Everything has a place. So, yeah, if you guys are a manufacturer and you want to get your product out there to showcase, you know what you're in for. So, send me something, because I won't say, you know, good or bad based on my own personal preferences. I will point things out from an electronics technician standpoint and a network engineer standpoint, because I do both. I repair the equipment, and remember, I also, yeah, program networks. So, you know, it's great to have this kind of insight. And don't forget, folks, help support the channel. You can subscribe to my Patreon and help out. I haven't really worked too much on it, but hey, this it costs money to run the YouTube channel, so if you want to help, go for it. If not, I will keep trying to fund it myself. So thanks, everybody, and like and subscribe, tell your friends, and have a great night. Bye-bye.